twice then.
Yeah. Well, I mean, yeah. Sorry, I thought those were questions for Rohan.
Mine was. Yeah.
Oh, yeah. Okay. Let's see.
Twice then.
Okay. Cool. Yep. Yeah. Well, I mean, all right. It looks like we go online. Okay. I'm gonna have to turn down that audio. Okay, I didn't actually think about that. Let's see. Okay. Cool. Yep. Yeah. Well, I mean, right.
Twice then.
Sorry. Yes, I'm gonna have to quickly work that out.
Might
Because
need
of
some
the delay
headphones.
with the audio on the YouTube stream, it's a wee bit messy for me. All right. Hey, hello everybody. Thanks for joining in. This is probably going to be a little bit of a messy start as we work out exactly this format. We're here today to talk about the new the Deluge firmware going open source. We've been asked a bunch of questions in advance on various platforms. So we'll try to sort of deal with those first, and then so please hold off asking questions on the YouTube feed for the moment, and we'll come to those once we're kind of like getting through this a little wee bit. One of the first things just to deal with that we've seen on a lot of platforms and a lot of people ask about is just sort of the debugging sort of systems and the hardware mods that might come with that. But the reason Aria got involved with us is they saved our bacon really and developed an amazingly affordable software-based debugging utility that meant that people didn't have to go down the road necessarily of the J-Link by Sega, which costs hundreds of dollars. But we realized that there's still a little hurdle to get over with actually doing the modification to the Deluge itself by putting a pin in, a cable, and routing that cable to outside of the Deluge. So what we're doing over the next few days, week, is we're going to put together really thorough documentation that explains just everything in detail, step by step of the parts you need to buy, where you need to get them from, and then there'll be documentation that you can provide any local electronics repairer who is, handy with a soldering iron and knows their way around a PCB, and then you'll be able to have that done locally rather than having to send it back to us in New Zealand. And we're trying to come up with we've got an idea for the least destructive way of modding the Deluge, possibly just having the cable run out through a side panel. So rather than actually like needing to Dremel the metal case chassis itself, you can actually just use the side panels. So worst case scenario, you just have to get a new set of side panels from us. So we're working on that for the moment. So you can expect to get some documentation on the GitHub, I guess, is how we're going to distribute that.
Makes sense.
Aria?
Yeah, sure.
Yeah.
I'll start tackling that documentation this weekend, and we'll see what we can come up with. Not everyone's as quite as adventurous as myself, so it's totally understandable if you don't want to cut a big hole in the back of your Deluge.
We'll work on something that doesn't freak everybody out and make you stress about damaging your Deluges. So yeah, just give us a few days, week to sort that out. All right. So yeah, for the moment, please hold off questions on the YouTube. Feel free to chatter amongst yourselves or make comments and feedback. But yeah, let's get to some of the questions that we've been asked. Rohan, is there anything you feel a good place to start off here?
Oh, hadn't actually thought about where to start. There's lots of questions.
So that question about the high-level overview of the hardware and how it's connected.
Yeah, someone was asking about I2C. That's not used in the Deluge. The relevant pins on the Renesas microcontroller, which could be used for that, are not used. So it's more SPI that is used for just the DC or CV DAC for outputting DC voltages to CV instruments. That is SPI or SPI, and also the OLED is also accessed via SPI on the same bus, which is how we were able to sort of hack that in and mod existing deluges. So yeah, mostly it's SPI. Of course, the external RAM IC has its own sort of parallel connection. There's UART going to, well, to the sort of secondary small PIC microcontroller that controls the LEDs and pads. Then of course the SD card has its own custom, sorry, not custom, but the SD interface, which is similar to SPI, is there as well, and USB. Yeah, I think that's pretty much most of it. Oh, and I2S for audio.
I can already sense this conversation's just going to be over my head all day today. Maybe we should start kind of from a bit more of a broader a sense with some of these questions. Are there things that you think people should look out for, or like, because there was that specific question, you know, what are the biggest limitations or potential gotchas that people might have to be aware of, rabbit holes you've gone down yourself? There's sort of, you know, what are the big hurdles you think people might need to get around if they're going to be in more and more complex?
One thing that's quite likely to catch some people out, which definitely caught me out at first, there are comments in the code and also in my code overview document to warn of this. But anytime you make a new object, really, a sort of a globally declared object, it's not going to get initialized properly or by default unless you do a special thing. For some sort of limitation of the Renesas code ecosystem, I'm not quite sure. But for instance, say instrument clip view, there was one instance of that class which is also called instrument clip view, just with a lowercase first letter. Classes like that have a constructor. The constructor is not going to get called by default, even though it should. So you have to, somewhere near the top of the sort of, well, the main function, or kind of the secondary main function in deluge.cpp, you'll see there are a whole lot of declarations that say that use the new keyword for every single object, basically. Anytime you create a new statically, I think globally is the correct term, object, you need to sort of redefine it into existence. There is a note about this at the bottom of the codebase introduction document under quirks, so you can refer to that. But that's something that I'm sure will catch some people out.
Quirks, yeah. Yeah, I say, Aria and Jamie, if you feel you want to jump in at any time and comment and expand on anything,
ask questions.
Yeah,
I'll chime in that whoever fixes that'll probably make Rohan very happy.
Yeah. If someone figures out a solution to that. It's a while since I tried. I did bang my head against it for a while, trying to work out what could be done. I never worked it out.
So is this a known problem for embedded systems developers?
It seems to be. Way back in the day, I posted on Stack Exchange, I think, about this, and it's sort of, someone sort of seemed to give me validation that it wasn't behaving as it should. Beyond that, I'm not sure exactly.
Okay, so it's a C runtime is not doing something it should be. Fire
basically, yeah. Or I guess C++, since it's a constructor thing. Oh yeah, and beyond the constructor not being called, also the pointer to the V table for classes that inherit from a base class, that also won't get set up. So basically, things will crash real fast. Another quick question I can see someone's asked that I just have a quick answer for. Is the hardware capable of USB high speed? Yes, it is. I think we just used low speed because that was sufficient for MIDI and for reasons of EMC compliance testing. It seemed that using lower speed was more likely to get us through that testing. How relevant that ended up being, I'm not sure, but yes, the hardware is capable of USB high speed.
Because I of course am interested in that as a way of making downrush work.
Yes, of course.
as well as, I'm sure, I think people would, I saw one question about MIDI 2. I don't
Yes.
know. There's probably
MIDI
a lot to
2.
be done to get that to happen, but
Yes,
I think
yes,
that's
there
pretty
is.
much the way people do it.
The hardware should support MIDI too. There shouldn't be a problem there. Yep, that should be fine. In terms of downrush, was it you mentioned something about wanting to it was beyond sort of sysx messages, wasn't it? It was about actually creating another USB sort of software connection to the computer.
I'd be willing to consider anything that gets the job done, since the flash air card is going extinct.
Yeah.
But in terms of which one's best, probably I'm thinking sysx. Well, I know people are going to want to be able to like mount the SD card as a file system in various computers. So that's probably, people are probably going to want that to happen. People are going to want to have USB MIDI happening. I think people will want a form of sysx, as well as more of a build out of the MIDI implementation, which is a good way to make it more accessible to people that don't want to get all the way into modifying firmware. So
Yeah,
we'll see.
of course. So USB is incredibly difficult to work with. I don't know if many of our users will have encountered that before, but in terms of well, the Deluge code that deals with USB is incredibly complex. Most of it is sort of copied or modified from code that Renesas supplied for I think it was probably more like an example of a computer keyboard that Renesas provided, that I modified to do MIDI. Also, actually, well, you mentioned mass storage, which would be a great thing to get working. And actually, Renesas did provide an existing mass storage example, which at least at one point, it turns out that was more similar to MIDI than you might expect. So I did sort of use that as a starting point. But in terms of getting multiple of these things working at the same time, incredibly complicated. I haven't tried getting any other USB thing besides MIDI working at the same time. It's hard to even know where to start. It gets so complicated when you start doing that stuff. But there is sample code from Renesas for things like USB mass storage that you could look at. But good luck if you're going to try them working at the same time. Super complicated stuff.
Could you be able to make that available, or is that something I should just go find on their website?
Yeah, it should be available just on the Renesas website. Yeah.
Finding anything on their website is a pain. So if someone turns up that link, please share it.
Of course. Yeah, I suppose you have to create an account and stuff.
I love how with Rohan putting out these challenges, it's just going to make some people like really hungry to solve this.
Hopefully. I'd like to know how to implement multiple USB sort of device classes simultaneously.
Beautiful. All right, there's a couple of questions here. Could someone wants a walkthrough of how the oscillator sync implementation works, as they don't recognize it? I'm curious. And then that yeah, basically.
Okay, oscillator sync. So pretty much everything to do with oscillators is highly optimized. I've optimized it many different times over the years to keep getting it working better and better in terms of just less CPU time spent doing it. Oscillator sync is one of the more complicated bits because, of course, it's well, obviously the oscillator is getting reset repeatedly, but also when you want anti-aliasing happening and for the whole thing to be as efficient as possible, basically, so oscillator rendering in general usually uses lookup tables. Each shape of oscillator, for instance, saw wave, is stored in a lookup table, but multiple different times. There are multiple different lookup tables for different amounts of harmonics, which I think that the equivalent in graphics is called a map. I'm fairly sure. Okay, Jamie's nodding. Yeah, so that is for those that don't know about anti-aliasing. If you, for instance, want to play a really high note at, for instance, 10 kilohertz, in order for there to be no aliasing, you have to make sure there are no harmonics or frequencies present which are above the Nyquist frequency, I think, which, since we're using a 44.1 kilohertz sample rate, the Nyquist frequency is 22.05 kilohertz. So you have to make sure that there are no harmonics which would be introduced above that. So basically, there is a lookup table for, I think it goes up this far, for say a saw wave which only has the fundamental harmonic and the second harmonic. Actually, I think there's even one that turns into a sine wave because it only has the fundamental harmonic, but it is still stored separately for the saw wave, just as well as in other places, just because that's easiest for the implementation. So there's all of that going on. I realized that was beyond the original question. So if that's a little bit over people's heads, don't worry about it for now. You can always work that out later if you want to. Of course, the code already does this, of course. So hopefully you'll be able to modify other things just fine without worrying about that. But in terms of oscillator sync, so the way that gets dealt with is, so it'll start, say, rendering your saw wave oscillator going up and up and up. That will sort of carry on however many times until it hits a sync point, when it will jump back, I think, down to the start of the saw wave. The way that gets anti-aliased is a really simple way, which is not amazing, but it's better than no anti-aliasing for that, where basically there is one sample, as in audio sample, of which there are 44,000 per second, which sort of does the anti-aliasing, which is sort of the average of where it would have been on the pre-sync wave and where it is after the sync wave. So this one sample is the average of those, but it's not just the average, because how far exactly left or right it falls of that sync point determines how close it is to the before or after level. So that's the result that you will see. In terms of the way that the code renders all of that and does it as efficiently as possible, this is a recurring theme throughout parts of the code base, including Wavetable does a similar thing as well. But basically, it will pre-calculate. Okay, so you will have hopefully read in my code base introduction, Deluge audio is rendered in windows, I say, at a time. The window can be sort of various different lengths. Say 20 samples is probably a fairly reasonable. We'll just talk about 20 samples for now. So when the code goes to render, say it's 20 samples of an oscillator sync wave, it will predetermine and look inside that. How many samples is it going to be until it hits a sync point, and when it knows that means it doesn't have to reconsider for every sample whether there is a sync point there. So it's like, okay, 10 samples and there's no sync points. The sync point is at the end of that. So it just goes and quickly does basically regular wavetable, not wavetable, just the oscillator lookup for, say, a saw wave for those 10 samples, because it knows nothing else has to happen within there. Then it knows it's at the sync point, so it goes and does that anti-aliasing thing I was talking about just before, and then it carries on again, thinks about whether there is another sync point for the rest of the window that it has yet to do. If there is, it goes and does that again. If not, then it just finishes rendering the saw wave or whatever. The code that does this uses C preprocessor stuff to sort of do all of that within a couple of different contexts without code having to be repeated too much. So there is a bit of that. It's a little while since I've dealt with that code. I don't remember exactly. Some of it's probably in voice.cpp. Yeah, I think there are a couple of other files where some of that C preprocessor stuff is. So yeah, that's a basic overview of how Oscillator Sync works. I probably shouldn't have spent so much time answering it, since I'm sure we've got a lot of questions to go through. Yeah, I'll try and be quicker with the next one.
Here's a question which you may be able to answer without, I mean, in the driver code, which parts were written versus which parts were provided by Renesas? Is that easy to answer, or is that kind of
most of the Renesas provided ones have Renesas a licensing notice at the top. So that's one way, that's probably the best way to work out. Some of the driver code has been modified by me, in some cases extensively. For instance, the USB driver for MIDI, as I mentioned before, was modified from Renesas source code. And other drivers have just sort of little inserts from me, which usually have a comment next to them. For instance, a lot of routines, like say for the SD card, while it's sort of waiting for some data to transfer, it goes and calls a function called routine for SD, which is written by me, which does audio processing and stuff while waiting for that data to come back. So that's used a lot throughout the SD card code specifically, but in some other places as well. I think possibly USB off the top of my head, and maybe a couple of other places as well.
This might be Jamie answer this. Someone just put this message up before. They ran into an issue when trying to convert a make file that was produced by E2 Studio into a CMake file to be able to build on Linux with the standard umnan-eabi toolchain. After getting the build to work, they tried flashing the firmware binary, and the Deluge rejected it and said, "Found firmware file does not contain valid firmware." Could someone quickly explain what checks are done to verify whether a firmware file is valid? Does that make sense to anyone?
Yes, I can explain how it determines whether a firmware file is valid. Basically, there's a string within the first few bytes of the firmware file that the bootloader looks for. And this was actually, I didn't exactly write this. This was set up in the basic Renesas example code. I think sorry, just one moment. I'm just loading up the file, which I think this is. I think it's called start.s. It's an assembly language file. I can't remember where it is right now, but it's in there somewhere. It defines a quick little string at the bottom. I actually forget what the string says exactly, but yeah, it appears within the first 4 or 8 bytes or so of a firmware file, and the bootloader looks for that to determine whether it's valid.
And there's just been various questions, I don't know about this, but obviously various platforms, how to do this on Macs, etc. Is this something that Aria was working on? Is it?
Sorry, what was the question?
There's been questions, people, they're building on a Mac.
Oh yeah. I'm currently in process of building a well, mostly copying a GPL'd build script setup. I've chosen to copy it from the Flipper Zero repository, because they use a very similar setup with an ARM processor, an embedded processor, and a need for cross-platform, cross-compilation in Windows, Mac, and Linux. And so I've started work on that. That exists in one of the branches of the Deluge repository. You can check where I've come up with that. It's SCONS and Python based, and it's going to rely entirely on internal tooling so that it does not mess with your operating system dependencies or install weird things in weird places.
Here's a question. Is someone going to provide a chart schema. I have no idea what this means. Where they can see the class structure.
No plans to provide a chart at this stage. Sorry, I realize it would be handy. We may get to it eventually. An easy way in E2 Studio to at least see the class inheritance structure is just to press F4 when you've got the cursor in the class name. If you just press F4, it comes up with sort of an inheritance sort of tree structure in the same window where search would normally come up. It's under type hierarchy. So just press F4, that will come up, that will get you some of the way, but that's just for class inheritance, not to tell you sort of which classes contain instances or references to other classes. We may do that at some stage, but we don't have that yet.
Yeah, there's I use a tool called Source Trail, which you can find on GitHub. It was recently made open source, and you can get it for Windows, Linux, Mac. And it basically does, it scans your entire source tree and does, creates cross references and so forth. And when you actually run it, you can click on a class and it'll make a UML type diagram visualizing what that particular class looks like. And there's ways you can get it to show you inheritance and some other things. It doesn't do everything, and it's just probably going to go into the relatively unsupported category pretty soon, but that helps keep me sane. Of course, I also found that a great way to learn this system is to, when you do get a debugger going, is to just, among other things, just hit the break button and see what it happens to be doing at the time you hit it, and do that a few times, and you'll find all the loops you need to find that the routines, I guess, to use our local parlance. Anyway, back to
I can just go through some more of the questions in this list, which people have asked. Someone asked about previous Git history or version control history. Sorry, but we're not able to share that. It was done in Git, hosted completely separately from the current GitHub repository. But yes, it was in Git. And unfortunately, we're not able to share it. But well, I'm not sure just how useful it would be. Actually, no, I'm sure it would be useful. But yeah, sorry, not able to share it.
Can you share more of your award-winning comments? The Discord's rather fond of your comments.
Oh, really? Which I thought I'd sort of edited the. Well, I definitely edited the swear words out before we made it open source.
I saw that comment of like, why did I do it this way?
Oh yeah, there's plenty of that. Yeah, often if I come back to a bit of code that I've written and don't remember exactly what it does, or if I think it might be wrong now, but I'm not quite sure, I'll put a comment so I remember that that's the case. Were there any other particular comments that the Discord liked?
Oh, there are a few. The one that stands out in my memory is, this is a temporary piece of code to do such and such. I don't remember what it was, but I'm sure that's been there a very long time.
Probably, yep. Yep. There's probably plenty of those. But perhaps that's the reason people would like access to the repository history going further back to find out exactly how long I had let that comment sit there. Well, yeah, it's probably been there for years, I think, is the answer.
Alex in the chat says, "Yep, that's fine," was their favorite comment.
Oh, excellent. The comment said that's fine, or just Alex says that's fine?
It was, "Yep, that's fine."
Oh, yeah. Yeah.
Okay, I have a question, which is, I'm trying to understand how much headroom there is, if you will, in the processor bandwidth to do extra stuff. Like, say I wanted to write a convolution reverb unit or something that's going to be computationally expensive. It looks like I have to break all the processing into like things that take less than a millisecond, or at least each bit of the processing takes less than a millisecond. Can you
there's not
on that?
There's not as much headroom as we would like for things like a convolution reverb. I did experiment with that a long time ago, and it seemed that it basically was not practical at all, but I did learn a lot more after that. And I did actually have a plan at some stage, which hasn't been followed through on. I did have an idea of a way that I might be able to do it better. I suppose with convolution, I think the the less instant it has to be. Like, for instance, if it's a reverb and it doesn't have to, the first sample of the impulse response, if that doesn't have to happen for a little while, say milliseconds or longer, I think that means you can do it a bit more efficiently. So that could be a good way to start doing it. There's, of course, that there is an FFT function there in the code base already that is part of the NE10 library provided by ARM, I think. A few places in the code call that function if you're looking for it. For instance, the wavetable implementation calls it when a wavetable is getting set up, and also pitch detection calls it. In terms of CPU headroom, you can hit the ceiling fairly quickly when you have a lot of sounds playing on the Deluge. The Deluge tries to make it as unobvious as possible by cutting out sounds that you're less likely to hear. Anytime it has to cull a voice, it will do one which is ideally already releasing, so it might have already got so quiet that you can't really hear it anyway. But in terms of when that starts happening, you don't get a whole lot of stuff. The Renesas processor isn't the most powerful processor in the world, but it can be used in ways that make it satisfactory. But in terms of adding big new features like convolution reverbs, it'd be a challenge, and you'd have to do it within the window rendering system. So you'd basically, if you were to create a function to render a convolution reverb, it would get called sort of several samples at a time, anywhere between, I think, even 1 and theoretically up to 128, but usually not more than about 64. So if FFTs were having to be performed, especially if you only had to perform 1 FFT every so often, you'd sort of have to figure out a way to get that happening occasionally without it suddenly taking much longer during one window cycle. So a bit tricky, but probably could be done to some extent.
Yes, because I know we have a lot of interest in the mutable instruments libraries. And of course, we have the advantage that most of them were written for Euro rack, and we're only expecting maybe 2 signals. So that would give you a little bit of something to work with. I'm not sure what types of processors Emily uses and so forth. But anyway, hopefully we'll be able to get some stuff like that done.
Yeah, and actually, you mentioned earlier, Jamie, in a message, floating points. And I think you said the mutable instruments code uses floating points. And this is something worth talking about in general with the Renesas processor. It generally is not good at dealing with floating points. They are much slower, about 4 times slower. Specifically, I measured this at least one time. I remember measuring it with the reverb implementation that the Deluge uses, which the original code for that uses floating points. So I measured its performance before and after converting it to used fixed point or integers, and yeah, about 4 times faster for using integers, slower for floating points. So unfortunately, writing code that's going to run well on the Deluge needs to not use floating points, or you can do it, but it will lower performance considerably.
There's a wee bit of a few questions on the YouTube feed about that, the pick code, which I think Jamie was talking about before we even started streaming. Is that right? Do you want to like quickly go over that?
Yes. So the PIC microcontroller, that refers to the sort of secondary microcontroller that just does only a couple of things. Deals with the LEDs and pads and buttons basically, and also actually has a vague influence on, or at least a connection to the OLED, just in terms of switching a couple of pins on and off, because these were the only spare sort of pins we could connect it up to when designing the OLED and its retrofit in. So basically, it's just a bunch of fast I/O to the LEDs and pads. The firmware for it is not open source. It communicates with the Renesas processor backwards and forwards with UART. And the way it operates, the way it references the LEDs and pads, it fires through the columns of pads 2 at a time. There's a total of 9 groups of 2 at a time. And while one of them is active, it will do the LEDs for those entire 16 pads and 2 columns, and then times RGB channels. So 48 outputs. Can't remember if there was a 49th that did something special. But yeah, it will do those, and then at the end of that, it will also read the inputs for those 16 pads, and then it will cycle on to the next one. But that all gets done external from the main processor on this small basic PIC microcontroller that just has a lot of I/O.
It has a protocol, a serial protocol through the UART. Is that I suppose we could try to figure it out. Is it kind of really simple, or is it?
Yeah, there were a few comments in the source code that specify what bits of it are. It's basically tries to use as few bytes as possible to get communication happening as fast as possible. There are most of it's 1-byte messages. The messages from the PIC back to the main Renesas CPU. Generally 1 byte, where possible, to say if a pad has been pressed. Actually, if a pad gets depressed, then basically just a second byte comes first, saying this coming up. This byte coming up as a depress rather than a press. I think that there's not many things that the PIC has to send back to the Renesas. The Renesas sending to the PIC, of course, it has to send colors, which it does. A column, or I think it's a pair of columns at a time, and then it sends a few other messages in terms of specifying the refresh rate and dimmer level and a few things like that.
There was just a question on YouTube, just referencing what you were just talking about with integers and floating points. Is neon integers also faster than neon floats, or is that the same? Neon is just a library, so it's not a particular type of variable, but what was perhaps being referred to, and what is worth considering, there is the, what's it called? Oh, neon. Yeah, sorry, I completely misunderstood the question. I was thinking of NE10 library. Neon, of course, yes, that is that operates on special data types. It's an SIMD, single instruction multiple data thing, where it's operating on, say, 4 numbers simultaneously. Usually in the Deluge code, it's 4 simultaneously. I think there's some cases where it's doing 8 simultaneously, but then they are only 16-bit instead of 32. So it makes things faster. I haven't actually used its floating point implementation, so actually that could be a good thing to test out and see if it is any faster. I suppose at least the fact that it would operate on multiple floating points at the same time, I'm fairly sure it has the capability of doing that. I suppose that would make it faster than operating on just one at a time. That would be a thing worth checking out. Definitely using it for operating on fixed point or integers. Yes, it's faster, and it's used in a few places in the code base, mostly to do with rendering oscillators. That could even be the only place. Oscillators, and also sample playback in the case where repitching has to happen. That's the place where it really has the most advantage in terms of applying basically a short impulse response, which is the windowed sync function, 16-point. It makes that much faster, but actually it's, and that's all fixed point, of course. And it made it about twice as fast, or something in that sort of order. So it will, even if you have it operating on 4 or 8 numbers at once, it won't actually make the code exactly 4 or 8 times faster. It won't be quite that good. And also, it took a lot of experimentation. You can sort of try, if you try converting a bit of code to use
to use those neon functions, at first, it might just seem that it's not going any faster at all. And in some cases, it just won't end up going any faster. But if you experiment with sort of using that code, just sort of rearranging things in that code as many ways as possible. For instance, the first time I tried to use it for that sample repitching stuff with the windowed sync, it was basically no faster. But then I tried sort of reversing the equation, or how can I put it? Basically, it's I think I had it, for instance, going through the sample, the audio playback sample, say a drum hit or something, one of this kind of sample at a time, the 44,000 per second type sample, and then had it going through them one at a time, multiplying it by the relevant a bit of the windowed sync, and it turned out I actually had to do it the other way around, and that made it really faster for reasons I was never quite able to find a good reason for. To instead have it going through the windowed sync, it's 16 points one at a time, and then multiply that by the samples and the source sample material. But actually, so I can't remember exactly which way around that was. I tried one and that didn't work so well, and then the other worked far better, basically. So experimentation is important, and floating points, not quite sure.
Great. Oh, is that Jamie asking a question on the YouTube?
Just want to make sure I'm getting in line with everybody else rather than preempting.
Yeah, timers for benchmarking. Yes, there are timers to use for that. There's a couple of different ways to do it. And it's a little while since I've had to do anything specific with those. Basically, that is all in audioengine.cpp. And also have a look in the header file, audioengine.h. No, maybe it's all in the CPP file. Well, maybe I'll have to come back to this. I'm sorry. Oh no, I'm in the wrong file. Here we go. Yeah, so there's a flag near the top of audioengine.cpp called report CPU usage. You can uncomment that and set it to 1. What that will do is it will make all the rendering windows all the same size, firstly, so then performance can really be compared. You won't get any sort of the window size won't change according to CPU usage, as is documented elsewhere, is the basic thing that will happen. So yeah, and then it will also report out of the RTT debugging text. It will report a number. I think it's how many clock cycles it took or clock cycles or some sort of timer to do that one window. So there's that. There are a couple of other things there. There is also a little bit further down in audioengine.cpp. There is a flag you can enable called do audio log. It'll be usable by people. Basically, if you're having issues, and something's taking up too much CPU time in audio rendering, switching on do audio log will have it sort of log things that are going on, and there are many parts in the code. You can have a search for this that call a function called log action and pass it a bit of text, pretty much just saying what the code is doing. Now, if you compile with that flag off, none of this ends up in the binary. It all gets cut out by compile optimizations, which is great. So none of this is slowing down things when it's compiled with that flag off. But while it's switched on, those various sort of log action things will be placed in this buffer. So it's not, rather than just have it print out directly to RTT, which would just absolutely spam it with way too much stuff, it creates this log for one rendering window with the time each action and also the text of what was going on. And then if the window took too long to render, so actually this has to be done separately of the of that other flag above, the report CPU usage one, which makes all the windows the same size. I think it has to be used separately. Anyway, it will, what that, the way that you then see what's in that audio log is if a window took too long to render, and you can set that threshold a little bit further down. There's actually a secret shortcut, which I think is still active. One of the pads, one of the unlabeled pads on the Deluge, if you go shift and into it. Jamie's got a question.
Okay, just brought up yet another issue, which is how do people are going to need to create user interfaces on top of what we already have. And there's probably a few places here and there where there are open key combinations and buttons that aren't used for something, but it'd be nice if there was a way to know what which ones to use, because there's so many, I can't keep them all straight.
Yeah, not sure I have an answer to that at this point. I suppose that'll be an ongoing sort of thing for that to work with the community on.
Community contribution if somebody wants to make it. Okay, anyway, I'll get out of the way here. But.
Oh no, not at all. And that was that was pretty much the end of that audio performance measuring thing. Oh, I just thought of another couple of one thing actually, but quickly to end off that audio log thing. Basically, if it encounters a window that took too long to render, then it will dump and print out the entire log of what happened during that window rendering, which it has, as you can see throughout the code base, there are a bunch of places I've had it log certain types of things where the code gets to a certain place. You can easily add more just by having it call that audio engine : log action function. So it'll print those out, and then you can hopefully have a look and see what was taking too long. Another way to see how audio performance is going is to watch to see how many voices are getting culled and how many are left. I think you can do this either with or without. Oh no, it prints this out by default if you've got alpha or beta version flag enabled, which probably most of our open source developers will have enabled a lot of the time. If you watch the RTT output, it will tell you each time it's culled a voice. And it will also tell you how many voices are still active. So basically, if you want to make sure that you can do, well, if you want to see how many square waves, say, you can sound at the same time, you could set up a square wave synth with a really long release time. This is what I usually do. And then just sort of put a lot of notes in on the sequencer and then turn the tempo up so it's playing a lot of them really fast. And because they have long release times, if you make it a polyphonic instrument, a lot of them will sound really quickly. Then you can just look and see how many voices it's having to cull it down to, which for just square waves with no filter or anything, I think it's over 100. You can get it to do. So I think that's all the main benchmarking things to be aware of.
Did Aria have a question here
related? I did, yeah. So I'm not intimately familiar with this architecture yet. I'm working on it. But of all the timers that are being used in order to execute various things, are there free timers that can be used for things like addressable LEDs, for instance?
I think in terms of hardware timers on the Renesas chip, pretty sure there's at least one that's not being used, maybe two that aren't being used. You'd probably have to look within the Renesas documentation to really get a good idea of that. Although actually, let me just pull up this file just quickly so I can just have a look. So this is in just main.c. This sets up timers before it even gets into any of the C++ code. The reason for that is there are some things that it seemed had to be set up in C before it sort of transfers execution over to C++. Although that was a while ago that I sort of determined that, and I couldn't work out why. So that's why it's the way it is. But there are functions in there that set up timers. There's one that gets called a few times for a few different timers called timer control setup. That's a function written by me that lives in mtu.h. MTU refers to the timer thing. I forget exactly what it stands for. But yeah, timer control setup function by me. It's you can specify what timer number you want to set up in terms of actually hardware timers in the Renesas chip. Just looking now, I think there are 5 hardware timers, and the Deluge code I think has used at least 3 of them, maybe 4, can't quite remember. But if you want to set one up, this timer control setup function should work for all of them. I had to. There are some things that are different between the hardware timers. I think this function will work for all of them, but you may have to consult the Renesas starter sheet. Jamie, you have a question?
Oh, yes. I was going to ask about interrupts and how they're used. I know I saw one for USB. Is it used in other places?
Yes, interrupts are used in a few places. Yes, there is a USB one. USB runs on interrupts in this implementation. Somewhere there's a flag within Renesas's code to specify whether you want USB to use interrupts or polling. Not exactly sure at this stage what would happen if you switched it back to polling, but it uses interrupts at this stage. Few other ones there. Okay, there are timer interrupts which go off within my code, which do it's mostly actually for the timing of MIDI and trigger or gate outputs to get them sort of sample accurate or within about one sample, because audio windows, as we already talked about, are rendered sort of many samples at a time. And originally the Deluge code base years ago, probably more than about 4 or 5 years ago, it did only once per window sort of send MIDI events and change the gate outputs. And of course, that could be referred to as jitter. A really helpful Deluge community member emailed me about this a long time ago, and I sort of got obsessed for a little while with minimizing jitter. And the way this is done is, a timer interrupt is set up for the exact right instance of the outputting, of a window of. Jamie.
Yeah. Next question is about DMA, direct memory access. I think I see some references to that in the code too.
DMA is used
handles the audio out.
It does, yeah. Now, if you look in definitions.h, let me just. I should probably share my screen, actually, shouldn't I? Let's see if I can do that.
Getting fancy now.
It's Ian, it says host disabled participant screen sharing. Is that something you can enable?
No.
I'll answer this question verbally if you wouldn't mind seeing if that can be turned on. That might make some things a little bit easier.
I joked earlier that we needed to get you a whiteboard.
I was actually thinking of having a bit of paper handy to hold up, but obviously that probably wouldn't work.
Can you try that? This is
it still says disabled, but it's not the most essential thing. I'm
not that experienced with Zoom, so I've got advanced
neither
sharing options on, and it says all participants if that's what the whiteboard sharing is. But
it's probably more than whiteboard. It's screen sharing, like the screen of my computer. I think it's actually in a different file. Try now.
Yeah.
Screen. Okay. It's just selecting which. Okay, here we go. Hopefully, can anyone see my code screen? Maybe not.
Yeah.
No.
I've got one participant can share at a time, and all participants can share. So, in theory,
is that working now at all?
No.
Really? Okay. How about now? Any luck?
I'm
got
seeing
our
a screen
spots.
that
Yeah,
says
there
you
we go.
started it.
Yes.
Code.
Yeah.
All right.
We got it. We got it.
Perfect. Okay, so DMA. All right, so we go into within the drivers folder, go to the RZA1 controller folder, which is the microcontroller that the Deluge uses. RZA1. Go to CPU specific, and it's in here. If you go to about the middle of the document, you can see there is this DMA section, which actually has this comment here specifying what the various DMA channels are. So there are a few unused ones. Yeah, it even says where the various ones are defined if you need to change them. A lot of them are defined right here, just below that comment. But there are a couple, for instance, the SD card or the SD host, as it calls the code, DMA channel number 2, that's defined elsewhere in SD_CFG. So basically, yeah, a lot of the DMA is already used up in terms of the 16 channels that Renesas microcontroller has. In terms of the actual DMA code for these various different ones is in various different places. There are a couple of functions, mostly written by me actually, which can be used to set up a DMA channel. But I find that all the stuff, DMA interrupts. Anytime I have to set up a new thing with that, it takes me about a day to get it right, because there's always just fiddling around. Things don't work right the first time, and then you have to try different things and then realize you've done something stupid. Yeah, doing anything new with DMA is a little bit tricky, but actually, yeah, a little bit more of this code is if you go drivers, all CPUs, DMA-C, the C stands for controller. Was this? I think this was written by me. Yeah, DMA-C.C. Well, okay, this just has a couple of functions which get called within throughout the code base, like DMA channel start. So yeah, that's a basic overview of how DMA works. Did that answer your question, Jamie?
Yes, thank you.
Cool. I'll just I can have a look through and see what some of the other questions are that we've been asked. See if I can answer any more of these, or if there are more here that I haven't answered already.
I think there was one question in particular about emulation and whether it would be possible to emulate the Deluge hardware, or I would venture even a portion of it.
To emulate it like on a computer?
People were talking about QEMU, yeah.
Oh, what's QEMU?
It's an emulation environment, virtualization environment that does support ARM, but as far as I can tell, has no Renesas processor support.
And I suppose it would also need, well, if it was going to be full emulation, it would have to have sort of a simulation of the Deluge hardware on the computer as well. In terms of partial emulation, yeah, I suppose something like that could work. It's not something I've ever worked on. I imagine it'd be pretty tricky to get up and running, but I'd be impressed if anyone can do it.
There's an additional piece I'll chime in because I've played around a little bit with it. Behind me, there's an image of a little pink board. This is the GR Lychee board from Renesas. You can only order these from Japan, but they have a very similar processor, almost identical to the one in the Deluge. So if you are purely doing processor-based things and trying to figure out how to get them done, it might be a solution. But as for simulating the Deluge hardware, very unlikely.
Cool, thanks for sharing.
Are all the VA waveform wavetables under the hood? And if not, where in the code are they implemented?
Well, what's VA in that instance?
Virtual analog, is that what?
Oh yeah, yes, I'm sure. Yes, they're in the code. Sorry, let me just turn my screen share back on again. That's probably a good way of doing it. Sorry, just 1 second. But a verbal quick beginning to that answer is they are in. Have a look at lookuptables.h. That's where a lot of that stuff is at least referenced to begin with. Actually, that contains the sort of the definitions for where those are. The actual code, it's those tables themselves are this is just in the source folder, no subfolders or anything. There's it all starts with, the file names all start with lookup tables. So there's lookup tables _analog_square.cpp and similar ones for other ones as well. So yeah, you can look in there. I'll just share my screen again. Everyone can see my screen, right?
Yep.
Yeah, cool. So this is lookup tables analog_square.cpp. So this has a lot of stuff. So now we're looking at the smallest window size. This is window in a different sense to the window audio rendering system I've been talking about. So this refers back to something I mentioned way back at the start of the talk in terms of the MIP-BAP sort of thing, where for each wave type, for instance, this analog square, where different copies of it are stored with different numbers of harmonics. This is the one that has only the one harmonic, so it ends up looking exactly like a sine wave, but it's stored separately for convenience. And then further down, there are more versions of this which not only have more harmonics, but the table is larger in order to be able to represent that information in a way that's not going to cause further aliasing or anything, because these lookup tables are only linearly interpolated for performance. So basically, the table is just made really nice and big, so that linear interpolation will still give a nice smooth version, because using anything good or fancy like windowed sync would just slow things down so much. So it's a trade-off for larger lookup table size for less CPU power. And as you can see right down the bottom of the file here, for the biggest lookup for this analog square, that has 1722 harmonics, which is totally what you need if you have a low note playing. You'll need you need that many, and actually no, scratch that. This is where that stuff lives, and there's a lot of it in this file. I think it's the quick answer to where those virtual analog waves live.
I'm actually just going to run to the toilet, but do you want to have a talk about fonts and go through that question that was posed there? Yeah.
Yes. So fonts, that's all, of course, relatively recent code because we only launched the OLED relatively recently. So that is under, where is it? I think it's under OLED low level all CPUs. So that's under source, drivers, all CPUs, OLED low level all CPUs. So the fonts themselves are stored in this fonts.c file. We had a question about the orientation of the fonts in the file. Someone noticed that they were sort of at right angles to what they were expecting and to what that tool spits out. This is the tool referenced at the top of that file there, that font conversion tool, which outputs just hexadecimal or binary. I think it output hexadecimal actually. What I actually had to do, I had to manually, I wrote this other code, just C code on my computer, to rotate those fonts 90 degrees because of the way that the OLED works. It wanted them at 90 degrees. So initially I had code that just sort of manually did that transformation as it was putting them on the display. But of course that was a bit slow. So by pre-rotating them, that worked well. yeah, so in this file, there's many different fonts, well, many different sizes of fonts. There's that Apple font up there. I'm not actually sure why it's called Apple. I don't know if it has anything to do with Apple computers. Ian, did you ever come across that? It's just called Apple, and it's a free public domain font. That's the main sort of small one that's used on the OLED. Then further down, we've got this font by Klim Type Foundry. This is the source is here of the files I made from that, but it's as it says in the file here, you have to purchase a license from its creator if you want to use it in a project. But yeah, the various different sizes of that are down here as well. Let me look at some more of the questions we've been asked.
Is that a question around the demo of the model stack? Is that kind of similar?
Yeah. So the model stacks, this is a solution that I came up with. There's documentation about it in my codebase introduction document. It's just for those that haven't read through that yet. It's just a basic way of it's an object whose pointer can be passed between functions, and it just sort of stores what those functions are dealing with. Clips, the song, even just pointers to those things, so that the functions being called just have quick access to that, and it's only one pointer that's having to be passed between those functions, and so it just references one object or a little data section in memory. So there's minimal memory copying and various other advantages as well. In terms of examples, it's pretty prolific among the code base. And of course, you can easily also just search for instances of it. In terms of maybe a best example to look at, it's hard to pick one off the top of my head. Maybe, for instance, note rows, which have functions in them. I'm thinking of the function to sort of do a tick forward, process current pos. This is note row : process current pos. It's in note row.cpp. So this is the function that gets called on a note row when it's time to move forward a bit in the sequencer. Often, this is a bit of a side point, often usually it will be moving forward multiple ticks at a time, a tick being sort of that minimum granular level, which is very often 3 times 128 ticks per quarter note, fairly sure. Anyway, so this gets past a model stack with note row, which contains, we know that contains everything down to the note row level. So it will have, actually there's not too many things above that. So it'll have the song, it'll have the clip, and then there's the note row. I can't remember if there's anything else above that. Let's just have a look. So this is a little bit cluttered, and I don't expect it to make complete sense all in one go. But so this is the model stack.h file. We can see that model stacks with note rows inherit from model stack with note row ID. So that reminds me that in order to have a model stack that has a note row pointer in it, it also needs to know the ID of that note row first, or as well. Note row IDs, that can just be the MIDI note number, like C60, for that row. That's how it is for non-kit instruments anyway. So that is available to, or when a note row, for instance, is processing something with a model stack. So as we can see, the way that's used when this function gets called, it gets the clip out of the model stack. This function is called get timeline counter, because clip has a base class called timeline counter that gets used for a couple of other things as well. So it gets that from the model stack to do. Then it can call some other functions on the model stack to make things nice and easy. We want to know the loop length. It refers to sort of the loop of what's currently going on at this sort of level. Like we have a note row and a clip. What's the loop length? Usually it's the length of the clip, but if that note row has a separately defined length, which you could think of in terms of being a part of the Euclidean sequencing implementation. But basically, this is just a nice function we can call on the model stack to get all that stuff. So if we go into get loop length, you can see the model stack. It checks if there is a note row, and because occasionally it could be null, I think is the reason. Or actually, maybe more than occasionally. And yeah, it checks if that note row has independent loop length. So of course, the note row could have just checked this on itself, but it's really valuable to have this in a function here that's being referenced many different places in the code, so that if that requirement changes in the future, that's just nice and central. As you can see further down here, if this was not true, if we didn't have a note row or it didn't have an independent length, then we would check the timeline counter, which usually is the clip. I think this is, yeah, that's a virtual function, so it changes depending on the timeline counter. I won't go further into that for now, but yeah. So this is back in that note row function that we're mostly talking about here. It can also check on the model stack whether we're playing reversed, which can be defined at the note row level or the clip level. So there's that code there deals with that. I suppose none of that is really specific to being a special thing about a model stack, but further down here, you will. Okay, this is an unusual case where it actually has to clone the model stack. We won't worry about that for now, because that's unusual. Usually the one model stack can be just sort of dealt with continuously. There's just a few cases where it has to actually be cloned, so we know we won't overwrite our current one. Okay, so further down here, so this is still within the note row, still within its function, which ticks it forward a little bit, dealing with param managers. I won't talk about those too much here. There's endless sort of rabbit holes I could go down. Basically, param managers manage params. Obviously, that's all I'll say about that for now. But we want to actually query or just sort of pass execution to that param manager or call a function on it. Now we've got our model stack here, which is the model stack with note row. We now want to add some more things to it, so it's got the right things handy when it gets where we're sending, where we're passing it next, which is param manager stuff. So we can actually, so we want to create this thing called model stack with three main things. The three main things, and I realize this is a lot of information to just be saying all in one go, and I don't expect people to necessarily be following every word of this. The three main things are, oh my God, can I remember them? There's the param manager, there's the mod controllable, don't even ask yet why that's called that, and then what's the other one? The sound or something? Yeah, okay, let's go in and see what those actually were. So fortunately, the model stack has a function to just sort of automatically populate some of that stuff. It can tell that, sorry about this, it's pretty complicated code in total. So the mod controllable, which in this case, it's usually, mod controllable is a base class of sound, among other things. So basically, some more things are getting added to the model stack, basically including the sound in most cases, which if it's a kit will be the individual drum within that kit. Otherwise, it will be the output of the clip. Output usually means the same thing as instrument, which can be a sound as well. So it populates that and also populates the param manager so that we know we're talking about those things when so it's created this new pointer, which actually points to the exact same bit of memory, the model stack. This is just a convenient way to know that that model stack now has extra stuff added to it. So we now know that it's a model stack with 3 main things, because that's now the type of pointer that we have. It refers to the same memory, so nothing's actually been copied except that we added those things, those new pointers within the model stack. But yeah, we now have this pointer to a model stack with 3 main things, and we can now pass it to places that require that it be a model stack with the 3 main things. This is so this perhaps shines a little bit more of a light on the advantages of this implementation. We can have functions which are specified to need a model stack with a certain amount of stuff on it, like this function it's not able to just receive any model stack. It has to receive a model stack with the 3 main things on it, which we can only get by doing something like supplying those 3 main things, or calling this function, this add other 2 things automatically function, which then gives us a pointer to a model stack with 3 main things. So the idea is that it's sort of not too breakable. You won't have the issue of passing a model stack pointer somewhere and it not having the right stuff, because you only can do it, but you get a compiler error if you tried to pass it a different one of the further up base classes of model stack that didn't have those things. So yeah, now it can get passed to a few more things. This is to do with ping pong mode. Obviously, don't worry, that's more of a fringe case than we're sort of dealing with in total here. Down here, it gets passed to the param manager, which manages. In this case, it's just the param manager for this note row. So this is really, especially if this was a note row within a kit, there would be a lot of params, like all the normal sound params per row, like filter, cutoff, resonance, the 2 different oscillator levels, pulse width, all those things. So we need to tell the param manager that we have progressed the position so that any parameter automation can happen for that new position. And so this is sort of the end of this quick example. But yeah, the last thing that happens here is that we then call process current pos on the param manager, and we have to send it this model stack that we've just added some more things to, so that it has access to those things like what's happening here? Where is it getting the model stack with param collection? Oh, okay, this is a complicated one. This has some pre-processor stuff, so don't worry about that for now. But basically, hopefully some of that made a little bit of sense. And if you want to have a look at that model stack example to get your head around it a little bit better, it is in noterow.cpp in the function noterow : process current pos. I hope some of that made sense. Thanks for bearing with me.
There was some appreciation of the of all that in the YouTube feedback. James.
Oh, really? Someone liked my idea.
Yeah, I'm gonna have to get going pretty soon, but I'm curious. I see places where you're talking about how deep the stack is, and is there a limit there that we need to be wary of?
Yeah, good question. You don't need to be too wary of it, because I set it to quite big. Just trying to remember whereabouts in the code base it actually is set. Basically, I think it's 8 kilobytes, and the code mostly doesn't ever use more than about 4. Originally, actually, this was a problem, because with the basic memory allocation just like pre-supplied system or code from Renesas, it was really unclear where the heap ended and the stack began. I did have instances of getting beyond the end of the stack, and then it would eat into heap memory, and yeah, it'd be chaos. So now that the Deluge has an entirely custom memory allocation system, which is detailed in my codebase introduction document, that leaves I think 8 kilobytes for the stack. Yeah, can't remember exactly where. I may as well just have a quick look. Oh, I think it's specified in. Have a look at general memory allocator.h and .cpp. That has a bunch of setting up for where memory goes. It's general memory allocator.h and .cpp.
There we go. Yes. Yep.
I turned my screen sharing off. I'll just pull that file up, just in case anyone wants to. If it's on the screen, people can refer to it more easily. But yeah, have a look in general memory allocator.h.
I see it as a collision detector, or at least you can enable a collision detector. So.
Oh, okay. That's another thing to talk about. And actually, I think this. Oh yeah, this is a function that I made. This is a function you can call for it to check at that moment whether the stack is anywhere near colliding. And here is that preprocessor thing that sets what the stack size should be. Program stack max size. This is just an instance of grabbing that value. Whereabout that is defined. Okay, it's in definitions.h, and it's set to 8 kilobytes. So that's program stack max size, but you probably don't need to worry about it usually. And in fact, this will get automatically output information about this with RTT text outputting. If you have alpha or beta version flag enabled, then this function it gets called from a few different places in the code base, which are pretty deep into the stack, like many function calls deep, and it checks this, and it will print out each time it reaches a new sort of depth into the stack, like further than it's seen before. It goes, okay, this is the closest we've been yet to a collision. Let's print it out so that the debugger or the programmer, I mean the person doing it, can see how many free bytes are in the stack, and it also has a little text thing to tell you what function that is. So this you may have seen this if you've used RTT debugging and run the Deluge source code. You probably will have seen it when you first boot it up, saying this many free bytes, blah 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 blah. Yeah. So those numbers will give you a rough idea of how close you are to a collision, but you should be like 4 kilobytes away or something like that.
Okay.
Was there anything else you want to quickly ask Jamie before you shoot off?
I think I'm sure I'll think of something when I'm driving on my way home, but I think I'm fine for now. I'll look at the video if this thing goes on much.
Awesome.
Longer.
Thanks for hanging out so far. Anyway, we've
thank you, Jamie.
Yeah,
delighted. I'll be around for about I don't know, another 10 minutes.
Oh, sorry, Aria.
Can I jump in quickly? There have been a couple questions about the memory fix that was put into the OLED version, but not the 7-segment version in a previous release of the official firmware. I'm not sure of the specifics around that, but maybe Rohan, you could give some clarity as to for starters. There's talk of it being 2 separate code bases. I know that it's a single code base behind a toggle, but how easy might that be to implement in a future community release?
The memory fix. Are they referring to there was a sort of a memory leak type thing? Do you think that might be what they were referring to?
I think so, yes.
I can't actually remember exactly right now. That was, I think, in the first couple of firmware releases, when we first released the OLED, and we quickly iterated on firmware releases, that the first couple there was some problem. I'm actually struggling to remember off the top of my head. Sorry, let me just think for one couple more seconds. What was it? Basically, I mean, it is fixed now for both code bases. I mean, well, the one code base that can be compiled both different ways. It's fixed in both of those. Of course, we're always taking bug reports and any remaining issues we're always interested in hearing about and debugging further. But that particular instance of that issue has been fixed. I'm almost remembering what it was. I think it was largely that something was being called in an interrupt that should not have been called in an interrupt. And occasionally that was happening at the wrong time, causing chaos. Pretty sure that was what the big problem was there. So, and that's right, that was specific to the OLED, the outputting of the SPI data to the OLED, which contains all the graphics and everything. Yeah, a function was doing that at the wrong time. That was the nature of that problem.
Okay.
There is a bug fix update that Rohan's working on at the moment, but I think it's not, that's already dealt with the leak. Yeah, it's dealing with other things. Yeah. That leak. If I can't remember why I called that a leak. Actually, there may have been another bug that I've forgotten just now. Sorry, but basically, yeah, those are all fixed and have been for the last couple of firmware versions released. At the moment, the next bug fix firmware release that's coming, the main thing I've fixed in that is there's no longer the limit on how many files can be in a folder, which is a totally silly limit that definitely had to be fixed. That is now fixed, pending further testing, and that's coming soon. We'll come to the YouTube questions soon, but we just got to get through a couple more of these pre-questions. Was there anything, Rohan, you wanted to talk about, clusters or audio buffers or whatever time stretch that weren't answered in your code base introduction? Someone did ask a question here, but you have talked about that in the question. I'd like to hear about the clusters that I see in some sample playback and time stretch code. Is this just a clever name for audio buffer lists, or maybe connected to an underlying strategy for playback?
So clusters, and there is a bit of an outline on this in my code base introduction document. But yeah, clusters, it refers to clusters on the SD card, but cached in memory is usually where the code is referring to this. So a cluster object sits in memory. This is one thing that could look a little bit confusing. The cluster, the object, if you go and look at the class cluster.h, may as well. Oh, I wasn't actually sharing my screen that whole time. Sorry. I'll switch that back on. Yeah, so cluster.h, the cluster class, contains just a little bit here at the top referring to this is. Yeah, it stores like the sample that it belongs to. If it belongs to a sample, they usually do. But actually, what happens at the end of an object, which is a cluster class, there's actually there's the empty space at the end. Well, basically, how can I put this? A lot of data in RAM directly after the cluster object is then used almost as part of the class, but that's used as the cache. So it's that's the data down here, and it's only defined as being as long as the cache line size, which is only 32. But in fact, there'll be many kilobytes there of cached data from the SD card for an entire cluster. A cluster is usually often 32 kilobytes, but I think can be as small as 4 kilobytes or maybe as big as 128. So depending on, that's just down to the file system on the SD card. Anyway, so a cluster object in RAM, its main purpose is to just cache some of that data, or cache or load or store, you could say, because it doesn't always necessarily cache it for later. Sometimes it just loads it and uses it immediately. But yeah, cluster objects in RAM, their main purpose is for playing back audio data from the SD card. It'll be loaded one cluster at a time, and then they will be played. It goes much, much deeper and more complicated than that. Refer to the codebase introduction document, which does explain much further than that, the way that they are cached and recycled, or stolen is the key word that gets used here. So it's to do with memory caching. You can read more about that. Ian, you mentioned time stretching as well. That's probably an interesting one to talk about, since I haven't written anything about that elsewhere. It's no more related to clusters than any other part of the audio playback. But the way that the time stretching algorithm works, basically, it's pretty basic. It doesn't do anything with FFTs or anything. It's a windowed style approach. I don't think I'll pull up any relevant code, because there's a lot of code spread over multiple files that does this. But basically, it'll sort of be playing from one bit in the audio file, and then say we're stretching, or say we want to condense the audio to play through it faster, but without altering pitch or anything. It'll be playing this one little bit. I think it refers to them in the code as playheads, and there'll be two at any one time, and they'll be cross-faded between. So there'll be one playhead here, then it will start doing another one over here a little bit later. So we've skipped a bunch of audio. That one will be going there. Eventually this one finishes and sort of fades out, and then it does a new one over here. So at any point in time, there'll be two playheads. It will decide exactly where to put those in terms of an analysis of the percussiveness of various different places along the file. It will sort of, you could say it's searching for transients, but it's a little bit more sort of simple than that. Basically, it will, so the classes relevant to this, well, it's not so much classes actually, but percussive or perk cache is what this gets referred to. Caches this stuff because it's sort of hard to calculate, and it wants to know it again later. It will sort of pre-calculate or calculate a bit in advance for an audio file. It will sort of scan through it and use a very basic algorithm just to see how percussive things are at any point in time. So it won't like narrow in and go, okay, the transient is right there. It'll just be like, okay, going along, it's a little bit percussive. Oh, suddenly it's got more percussive, and now it's less percussive again. Now this data actually gets condensed quite a lot, because it doesn't really need to know that for every single sample of audio data. I think it gets condensed something like 128 times, so that the memory, so that the data takes up less space in memory. Anyway, that determines where the most percussive bits are, and that is where what happens. Well, that's to do with deciding where the playheads should be for time stretching. It's more complicated than that as well. Yeah, there's more stuff that goes on, so that you don't get too much of a warbling effect when, for instance, time stretching one constant tone, let's say a square wave just at a constant pitch. If you try and do like a windowing approach to that, you're going to get artifacts unless you do some extra stuff. Like if it's if you're stretching out a wave, say a square wave, or actually let's talk about sine waves, because they are even more sort of basic, and you'd hear artifacts even more clearly. If it's got sort of stretched over itself, you hear sort of like bits of sort of, and it just will sound terrible. So it also makes an attempt to align the playheads so that waves will intersect as perfectly as possible. It does that. It's relatively simple, actually. I think it just checks sort of a few samples wide, sort of tries lining them up, trying a couple of different combinations, and seeing what one seems to line up the best in terms of just it like subtracting one from the other or something like that. So there's that as well. it's really, yeah, that's really all it's doing. A bit of randomness is thrown in as well, which seems to help to avoid sort of getting a constant pitch of the switching between the playheads, say, because if it was constantly doing a new playhead exactly the same amount of time apart, they'd depending how well all the other parts are working, you get a bit of a constant sort of it would probably sound a bit like aliasing or something. You'd hear a bit of a constant sort of pitch or drone. Also, actually, I just remembered as well, the percussiveness, that also determines how long each hop, it's referred to in the code base as hops often. I think I originally got that from some Wikipedia explanation or something. A hop is sort of it's referred, well, the way I did refer to it in the code, it is that's just sort of the length that a playhead is going to play before it stops, and then a new playhead has to be set up. They'll be closer together during more percussive bits, so that we're less likely to miss important percussive information. Like, for instance, if there's a drum hit, you definitely don't want that to be skipped over by the playheads. That definitely is a bit that you have to hear. So coming up to that, the hops will get shorter and shorter and shorter, so that we're sure that that we will hear that bit, that it won't get missed. Cool. I think that's a reasonably thorough sort of brief overview of how the time stretching algorithm works.
Cool. I'll start skimming through the YouTube as well, because some of the remaining questions we have also doubled up here, but there's a few people here at the start who are a little bit worried about the fear of bricking their device by, like, you know, using the community firmwares and stuff, or, you know, whatever. The
firmware can't brick a device.
I think this ties back to the discussion we had at the beginning prior to going live about the bootloader's capability to load firmware off the SD card.
Yes, actually that was a little bit different, because that was the bootloader checking that the firmware, once it's already in RAM, looks like valid firmware. In fact, when the firmware gets installed into RAM, I don't think that's checked for. And basically, one thing to watch out for, if you were to accidentally put a firmware bin file on your SD card, which is either 0 bytes or too many bytes, now that could be a problem. This has been fixed in more recent bootloader versions. In bootloaders on some of the oldest Deluges, that wasn't checked for, which is a big disaster. That's my fault. So if you were to try and install a 0 byte bin file, the bootloader would get confused and it would go and overwrite itself, basically. So be careful of that. Actually, probably should have brought that up earlier. Is there
a bootloader fix that we can distribute?
Sort of yes. Well, yes, but I was obviously I hadn't quite thought this through. I was hoping not to have to get people updating their bootloaders, because that is a time where things can go wrong. Like, if you're updating the bootloader and your device loses power, then you're really in trouble because the bootloader's gone. But maybe that actually would be a worthwhile thing to get people doing to save them from this other, maybe potentially dangerous scenario. This is just people that are working with you know, doing open source, building firmware themselves. Yeah, perhaps we should get them to update their bootloader. That is a very good idea.
Would you happen to know which board revisions, or, you know, pre-serial number, blah blah?
Not 100%. I'm not 100% sure, and it wouldn't correlate exactly to board revision either. It's at least any Deluge sold in the last 2 years should be fine. Probably longer ago as well.
So in the meantime, you think anyone who has a Deluge older than what 2022 or 2021 should wait for an updated bootloader or something from you?
Well, it's totally fine if you're using something like the Deluge probe or a J-Link to get the code onto your Deluge to run. That's totally fine because it doesn't depend on the bootloader. It just goes and executes stuff from RAM, or maybe with Deluge probe. I can't quite remember, Aria, whether that can put stuff into the flash memory. But again, that's
it can flash. It can permanently flash.
That's cool, and that will be fine as well, because that's still doing it independently of this bootloader that has this terrible problem that I wrote into it. But if you're going to be installing binaries from an SD card, if your Deluge is a little bit older, you definitely want to make sure that that bin file on the SD card is not 0 bytes and is not more than like 3 megabytes.
All right.
Until we sort out giving you this fixed bootloader.
And if someone was to make that accident in the meantime, is it a case of just like then having to just reflash with the new bootloader and new firmware? Like it's not going to permanently, you know?
So it's somewhere between permanent and not permanent. So basically what would go wrong is that the bootloader would be overwritten. So, well, maybe it's not so bad. So yeah, the bootloader will be overwritten. You wouldn't, by normal means, be able to boot your Deluge up and reinstall the firmware. But actually, if you did have like a Deluge probe or a J-Link, then there are ways you could get in there and fix it yourself. But otherwise, if you've overwritten the bootloader on your internal flash memory IC on the Deluge, at worst, it's a case of needing to put a new IC on there, which various repair partners can do fairly easily.
All right, let's get some information about that out there as soon as possible.
Yes. Yes.
All right. Scrolling down. Okay, there's this, which lots of people are asking, are there plans for a plugin style system? I mean, someone needs to write that.
Yeah, I guess that comes down to what the open source community, if someone wants to do it, basically. The reason I've held off from ever doing anything like that is that maybe there isn't a good reason, but other than it being a complicated thing that I just never got around to putting any time to, but also, yeah, I'm not experienced in making sort of plugins which are dynamically linked. If it really was a case of people actually writing, if it was a plugin system that involved compiled binaries with execution being passed to them from the Deluge firmware, that's not something I'm familiar with doing. I'm sure it's pretty complicated. If it was more an issue of like, or if it was done in a way where people make these plugins with just some sort of like basic code that doesn't actually get compiled, the Deluge just interprets it, that would probably run fairly slowly. And yeah, I guess also the thing of even if the plugins were sort of pre-compiled, yeah, I just don't know a whole lot about this. I feel like it might be, especially now that it's open source, it'd probably be easier just to modify the source code. But absolutely, if anyone develops any solution along those lines, that sounds like an awesome feature.
I'll chime in with maybe where someone can look. Again, because I'm familiar with it, the Flipper Zero repository might be a good place to glance at. It's slightly different architecture. They're an STM32 processor, but ARM as well. And they do have dynamic elf loading. So that might be a starting point for someone who's interested in pursuing that.
Cool. Thanks. That's great.
A few people have been asking about like expectations from like the official branch compared to the community branch, and I mean, we don't have anything that we're committing to at the moment, or that I mean, I think Rowan's been tinkering on things for a while, but part of the whole point of this process was to give this to the community to take kind of pressure off us and allow us to focus resources elsewhere. So we don't have any planned official releases. We're going to sit back and watch what happens with this for a while, and focus energies elsewhere. But it's possible Rohan might sneak in something, we never know. Maybe wakes up in the middle of the night, who knows. But yeah, don't but don't sit around waiting for something from us other than supporting this community thing and seeing how this goes for a while.
Will we see any enhancements in the community branch from Rohan?
Yeah,
not specifically in the community branch. Any changes I make will go into the Synthstrom official branch, and of course those changes can be merged over. But I don't think I'll be tinkering specifically within the community branch. Sure, you never know. I hadn't actually really thought of that. Yeah, you never know.
All right. What else are going? Sorry, just trying to look through and see which of these are questions and which of them are just people like speculating on things.
Or me trolling.
Yeah, we can't really talk to, or like, people are asking here about, would this feature be possible? Would that feature be possible? I mean, that's for the community to determine into how much energy people have. Okay. This is an interesting question. How many years of learning code do you think if it would take someone to starting from scratch right now to be able to get to a point where they could confidently muck around with this?
From scratch, if someone's never done any code, I don't know. I guess they want to know a number, say 4, if they're really into it, or less, to be able to do basic changes. I mean, within a year of study, you can write basic programs and code and stuff. So maybe within a year after that, you could change a couple of things within the Deluge code base. But yeah, this is it's probably more people that have a little bit of programming experience that will be able to do things quicker here. But if you want to learn how to code, I say do it. It's a great thing to learn.
I'd volunteer that it's hours rather than overall duration. If you put in the hours to have hands-on and try things out, you'll learn it quickly.
Definitely.
Someone here is asking Rohan for you to have a talk a bit about how the arranger view is created. It's a big question. And does the Deluge save an overview image of the arranger view with the song?
Yep. Yes, it does save that image if that's what you had on, if that's the view you were in when you saved the song. Yes, it saves that image. In terms of how it's created, much like the other sort of views on the Deluge, which all do inherit the same base class. Well, I think there's a couple of base classes there, but basically they have functions which will be called by the more general part of the code, saying like a pad has been pressed or a button has been pressed. Those functions are called pad action and button action, respectively, and various other things like horizontal encoder action, and they will do things like specifically the arranger view. Some things that it has to do is, well, scrolling up and down, of course, which is the same as the various other views. So when you do that, its vertical encoder action function gets called. Then it has to sort of re-render what's on each row, which actually is a fairly involved process for the arranger view, because it actually this might not always be visually obvious, but it actually goes inside the different clips and has a look at what notes are there, and sort of kind of blurrily puts that into what you can see in arranger view. You'll only really notice it if it's quite a long clip instance. You'll sort of see there's some color variation in there. That's from the notes inside that clip. Not sure what else I can really say about how the view is created. Other than that, it's C++ code. I may as well pull up the file now. Arranger view. It inherits from timeline view, which is a class that applies more broadly to song view and clip view, definitely. And that inherits from root UI, which inherits from UI, but okay, maybe UI is the best one to look at here. And you can see that it has virtual functions which behave differently for various different UIs. There's a pad action, button action, horizontal encoder action, all these different ones. Graphics routine, that's an important one as well. I think that's only for things that do constantly change on the display, rather than like the initial rendering. That's only for something like the playback head moving along. I think some of the things which blink. I think that's and a couple of render functions for parts that need to be re-rendered, render main pads and render sidebar. I think that's a vague introduction.
His question, does the audio input work with a dynamic buffer as well?
Yes, great question. It is a circular buffer, much like the audio output. It is also written to with DMA. So it comes in from the audio codec via DMA, or via I2S from the audio codec, comes into the Renesas processor that way. Then then via DMA ends up in a circular buffer in RAM. It's actually a really big circular buffer, something like 32 kilobytes or something like that. The reason it's big is for this special feature, the margins feature of audio clip recording, particularly if you're using the Deluge as sort of a live looper. There is that feature where if you when you sort of if you're using a foot pedal, when you stomp on the pedal to start recording a new clip, it will actually grab a little bit of that preceding audio into a margin at the start of the audio file if you've got this feature enabled, so that when crossfading needs to happen, it's got that buffer of extra stuff back there, which can be useful for time stretching, because we talked about time stretching actually being sort of crossfading of a lot of different little bits. Also, in terms of making it so there's no click at that loop point when it gets to the end of that audio clip and wants to go back to the start. It's just handy having an extra buffer at the start there, and an extra margin of audio at the start there. It's a long time since I developed that feature, so not sure what else I can say about how that works at the moment. But yeah, audio input, big circular buffer.
We talked a little bit earlier about USB, and that you haven't pushed the USB as much as possible, because the code is very, very complex and difficult. In your mind, do you think that the possibility of audio over USB is technically possible? Just requires someone to make it work, or?
Yeah, I'm sure it's technically possible. Very, very complex. As I mentioned earlier, all USB stuff is complex, especially when you want it to be doing multiple device classes at the same time. And then especially, I imagine that, when you have to learn a new type of device class that you're not already familiar with, like as an audio streaming device. Then it's complicated learning that as well. So yeah, there's a few steps, a few hurdles there. They're big hurdles. Someone that's happy to commit a lot of time would be the person to do that.
Now, you've talked a little bit about time stretch already. There was an expansion on that. If there are possible internal params that could be exposed, or maybe the current params be exposed as more granular.
Sorry, actually, I missed the first bit of that because my eyes had wandered over to the comments. What was the thing that people wanted to know was more granular?
I'd like to hear about how time stretch works. So obviously you've talked about that.
Yes.
And then if there are possible internal params that could be exposed, or maybe the current params be exposed as more granular.
Sure. Well, everything is exposed in the source code there. And yes, there are some values you can play with, mostly set up as C preprocessor stuff. Things like, I think, the default sort of hop length, or which is how long a particular playback head thing plays for. Let's just see what I can pull up here, because there are some. I spent a long time on the time stretching algorithm, which also applies for pitch shifting. I got quite obsessed with it and spent a long time working on it in about 2018, I think it was. I think Ian wished I would finish with that and make some new actual features, but I wanted to make the best and most efficient time stretching algorithm I possibly could. It's not here. Well, there's an extra flag there to measure some performance, but obviously that's not the thing. Somewhere, I don't know where, in order to make the time stretching sound as good as I could get it at various different stretch amounts, somewhere there's a lookup table that has sort of the best parameters for that window size, for that stretch amount. So, for instance, it might have been that when it's going faster, we need like shorter hops and a few other things. I can't actually really. It's so long since I've worked on that. I can't remember exactly what the different sort of internal parameters were. Yeah, I don't know where that. Oh, here it is. Okay, it's hidden sort of right in the middle of this C++ file. Probably not the ideal place for me to have put it. But yeah, there's this is for various different stretch amounts. So yeah, I've even labeled them here. This is it's in semitones, but as you could sort of interpret, -12 semitones means half speed. And I think these are interpolated between. So I think the value on the left here would be for half speed. The next one would be for like normal speed. And then the last one here is for double speed. Min hop size fine. Can't remember exactly what that does at this moment. I mean, obviously something to do with the hop size length thing. Okay, then max hop size. Okay, I think that might have been for, these are just limits for how short or long a given hop can be, as determined by probably other parts of the algorithm. And then, yeah, there are other parameters here which have variable, which have these lookup tables defined to happen differently at different stretch amounts. Crossfade proportional. Can't remember exactly what that does at this stage. Crossfade absolute. Well, yep, you're going to have to dig in if you want to know what this stuff does. Then this will be for the amount of randomness that is applied to essentially the hop length at different time stretch amounts. Yeah, these are things that people could play with if they want to see if they can get the time stretching sounding even better or more efficient.
Oh, all right, I'm a bit confused now about where I'm looking in the questions. Crikey. Okay, maybe people just got to ask questions again now, because I'm a bit confused as to what. So we're not really talking about specific features and if they're possible and that sort of thing. Like that really is just to see what the community of coders come up with. But if you have specific questions about like the code and its implementation. That's sort of what we want to be talking about here. Baymud, if you're having that problem with your 7seg, just send us an email about it and tell us everything you can about it, and we'll deal with it. Aria, did you see anything pop up that we... Oh, what's up with the Patreon?
Yeah.
I mean, yeah, I haven't worked out exactly how that will be distributed yet. I guess we need to sort of, at the end of each month, we'll just sort of see how much work individual coders and developers have done on the community thread where they're giving it back to everybody. So it's not like ones where they're just obviously going off and doing their own work and doing their own. We're not going to give people money from the community for that, but people who are spending their time and giving it back to everybody. And yeah, we're just the Patreon's doing pretty well. It's up to several $100s already. There's about 70 or 80 people contributing a month to it, and we'll just keep on trying to grow that, and hopefully just... Obviously, we know that the developer's time is worth way more than we're going to be able to give them, but it's just a sign, just a way for the community to show their love and appreciation, and for us to kind of facilitate that, and kind of, because I know that the people in the community want to do everything they can, and I know they're probably like frustrated at how little they can do. So this is just a kind of way of them to show their appreciation. Yeah, I guess. Okay, here we go. Here's a question. For an app like Deluge, which is meant to be a desktop-based app to, control your presets, songs, save things, talk to the Deluge back and forth, what method of bidirectional communication would you recommend over USB? How would you recommend building an API to access functions within the firmware?
Also, that question is from the creator of Deluge.
This sounds similar to I think what Jamie was talking about in terms of needing ideally for downrush, a two-way communication system. So I think Jamie's the person that's probably gonna lead thinking or dealing with that. I think they were talking about potentially it could be done with MIDI sysex. As I was saying before, any other sort of beyond MIDI, any other sort of USB protocol is going to be very tricky to implement. I'd love it if someone can actually do that, have other protocols going at the same time, but that's a tricky path to go down. It's going to take a lot of hours. So perhaps, I mean, MIDI sysex is probably the one that's most attainable right now. Beyond that, Jamie's probably the person to ask.
Is Synthstrom planning to implement all the not implemented buttons? As we just sort of talked about before, we currently don't have anything where, well, we have things, but we don't have any specific plans to release anything at the moment. We're just watching what the community does. So I think one of the earliest things the community should do is, I guess, work out all the available UI that kind of hasn't been used, or all the sort of best combinations. For example, right now, keyboard button in kit view doesn't do anything. There's the audition pads when you're in keyboard view don't do anything. There's all these possibilities, and I guess someone just needs to create an outline of all the available UI that is there without getting too convoluted with holding down 3 things at once. And and then people can start looking at maybe, for example, the sync scaling button probably is used by the tiniest portion of our audience. So it might be that some people are willing to give up that to a key feature that is more usable by them. So we don't currently have any plan, and there's also some grid buttons that currently aren't used as well. So it probably makes sense for someone to make a master doc, and then for the community to start working out the importance of features to be taking up the key UI and that kind of thing. Rohan, how is live transposing of audio input accomplished?
I'd love to answer that. I saw that in the comments just now. That's very similar to the time stretching, which of course also works for pitch shifting. So people probably already understand this, but time stretching and pitch shifting are almost the same thing. It's basically just trying to change one of those things without changing the other, trying to either change pitch without stretching time, or vice versa. So the input pitch shifting, it's similar. but it has a couple of other restrictions placed on it, which are, of course, that you can't see into the future. If we have this buffer of audio coming in, excuse me. Oh, and actually, now that I think of it, this is another reason why the input audio buffer is quite big, in addition to that margins feature I was talking about earlier. Because when you have different, well, two playheads in this case, sort of moving throughout that input buffer in order to create the effect of different pitch, you might need quite a bit of buffer there to be able to move around on. And so the key difference from the regular time stretching is that things have to be oriented around knowing that those playheads aren't gonna sort of get beyond now time into the future, which of course would, if it got to the end of the buffer, there'd be some sort of click or horrible noise, which I think happened plenty while I was developing it. And also you want those playheads to also be as close as possible to the end of the buffer, because you don't want too much of an audible delay. So those two things had to be taken into consideration. I can't remember off the top of my head exactly how I solved either of those, but it was a similar thing. I think there was some measure of percussiveness still. Yeah, you can. The code itself is in, what is it? Live input buffer. Oh, maybe that might be at a more granular level. Live pitch shifter is where all of that stuff happens, and it's similar. It started out as just a copy of the code from Time Stretcher, but it was different enough that it warranted its own entire file and version of the code. Someone else was asking in the YouTube comments just now, what do I feel is so difficult about USB? There's just a lot in the standard compared to something like UART or SPI or I2C, where you can easily talk about or understand from a few diagrams and that sort of thing what's actually happening at the hardware level. There's sort of, well, for various ones of those, there's either 1, 2, or 3 different wires. And as a developer, you understand what each of those wires is doing when it's high or low. One of them's a clock signal, except for UART. It's fairly easy to explain what they're doing. At USB, I still don't know, and I think not many people know what's actually happening at the level of those two wires, the D plus and D minus. The hardware takes care of that, and I think that's almost always the case in almost every device and development environment. The hardware, in this case, the Renesas CPU, handles that stuff of what's going on at the actual input-output physical level. That's sort of obscured by these concepts of things called buffers and endpoints. And I think some other language that I'm not remembering right now, but it's the system is obscure, and part of that obscurity is handled in hardware, like that whole thing with the setting up of endpoints, except in software, the software has to deal with them as well. There's a Renesas software driver, and of course, for the various different environments that one might do some USB programming on, like even sort of on a desktop computer or something. This is all largely handled by a driver, but at least in the case of the Renesas microcontroller, well, the driver isn't really distinct from the actual device class. Like I think they might not even call it a driver. Maybe it's more of sort of example code, but there's the code that will implement a USB mass storage device, which is Renesas provide that, and that's, I think, what I originally sort of modified in order to get a USB MIDI device. But yeah, it's not, at least with the Renesas example code, it's yeah, the code the code example isn't really separate from the driver. Like you can't really pull the driver out of their mass storage example. I mean, I sort of did, but really it was a modification of that entire system. And then other things such as getting multiple device classes going at the same time. That's tricky. I think I've at least wondered how it works. I can't remember if I've actually tried to do it. I feel like I've at least looked through the code wondering where that would be, or just USB has occupied a lot of my attention, or just hours of me sort of staring at it or experimenting with it, trying to get it to do things. What else can I say about it? Basically there are at least a couple of levels of abstraction there. You could say there's the hardware level, and then there's the software level, and then what you're dealing with as a programmer is just hugely abstracted from what the actual D+ and D- lines are doing. And there's just a lot of terminology and stuff in there. Like if you try and look through the Renesas documentation for its USB example, for USB implementation, it's just, I still don't understand what most of it is talking about. So yeah, complicated.
Awesome. Cool. Yeah, I think, I mean, so we're going to do another one of these sessions as well in a couple of days. So I think it's probably best just to sort of wrap this one up now, and then we can leave the video online for a couple of days. People can watch it, come back to it, maybe like come up with some questions for Rohan on the second session. If there's anything burning, please ask now. Aria, did you have anything that you wanted to?
No, I think we've gotten through most of the stuff that I have for questions. I haven't had a chance to dig into the source code because I've been working on all this peripheral stuff. So once I do, trust me, I'll have some questions.
Yeah. And we will try to get some explanation over the details around bootloaders and what to do with all that very, very soon. But just basically, yeah, if you have an old Deluge currently right now and you're going to be like flashing new firmware on it, make sure it's not 0 kilobytes or over 3 megabytes. Was that right, Rohan?
Yeah, that's right.
Yeah, and we'll try to make sure we get really accurate detail out to everyone soon.
When I work on the build system, I'll also make sure that any flashing that's done through the build system checks for those things.
Awesome. Hey, yep. Thanks again, everyone. And yeah, we'll maybe see a few of you in a couple of days. Otherwise, yes, just ask after 2 days. Allow us time to answer new questions within the new video, and then please watch that. And then if you have questions that haven't been answered in these 2 videos from this weekend or next week, then hit up the discussions threads and stuff on the GitHub, and hopefully someone will get back to you really promptly. All right. Thanks, everyone.
Thanks, everyone.
Thanks all.